During last semester in the Energy and Transformation course, I learned about different types of physics topics, some of them interesting and some others not. One of them is friction, and you might be wondering what is it? Well, every time an object passes through a surface or fluid, it generates a resistance that allows the object to move or not. It is not always the same and depends on the materials of the surfaces. Any kind of displacement is followed by energy, which produces work. Also, every surface has a force that makes this displacement less effective. Here in the first image, we can see a diagram of work done by friction and the formulas that are needed to calculate it. In the other side, we have the thermal energy. That is the force contained in a body which is responsible of its temperature. Thermodynamics is a branch of physics which studies how heat it is transferred between different bodies and how it affects. To measure this thermal energy, we will use the following formulas, and also we can see a diagram of thermal energy. For the experiment, I used some ice cubes, a square tray, a square piece of wood, two square pieces of steel, a square piece of ice, a ruler, and we can identify our variables here in the experiment. And our variables, the dependent one is the amount of water produced. The independent is the surfaces, ice, steel, and wood, which will be the changing in the coefficient of friction. And the control is the initial angle when I slide the container. To measure to make my experiment, I needed a tray, a cup of medicine, and some pieces of wood. As you can see in the bigger image, I've got a picture of my project, of my experiment done. And I used the cup of medicine to calculate the water. And also I used the tray to slide the different the ice into different surfaces. To make this experiment, I will need a base in which I can keep balancing the ice cube. It will be crafted with the steel pieces and it will look like a scale. In this way, I can be sure that I will be launching the ice cube from the same angle and height every time. Then I will modify the tray to have three different sections of the different materials I mentioned before. As I said, I will start launching the ice cube at the same height and angle for 2 minutes. After that 2 minutes, I will collect the water produced by the friction and so my hypothesis will be proved. After sliding an ice cube in different surfaces, I obtained the following data. Now, the results. What I got of water produced from ice was 1.3 milliliters. From steel, I got 4.0 milliliters, and for wood, I got 3.0 milliliters. When calculating the work done by friction of the different surfaces, I got here some results which were very confusing because some of them weren't like logical. So I think I may have got done something wrong. But here's an example of how I obtained the work done by friction and some of my tables done. Here, this is the tables and the data collected from the thermal energy produced. I also put an image of how I obtained this thermal energy, and I put a table and and a graph that can show us better the relation between thermal energy and coefficient of friction. Now, my conclusions. What I can conclude is that if the coefficient of friction is big, the object that will be slide will gain temperature because it's harder for it to get through it. Also, if there's a big coefficient of friction, it will be more force against produced. I think I can improve my way of recollecting info and the way in which I did the experiment because, as I said, I got impressive data by getting weird amounts of water that weren't logical. I could have done a better measured box with more controlled movements.